Aloha and welcome to our video on metamorphic rocks. In this one we'll predict where most metamorphism takes place and distinguish between contact and regional metamorphism. We'll identify the three agents that cause metamorphism, and then finally we'll classify metamorphic rocks as foliated or non-foliated. So for metamorphism to happen, we're talking about two things. We're talking about applying heat and pressure. Okay, so now where are we going to find these things? Well, pressure is going to happen the further down we go, below the surface. That's going to add this pressure. And then heat, we're going to get a lot of it from this idea of magma. So we can have regional metamorphism and then contact metamorphism. Contact metamorphism is where it comes in contact. So if we take a look over here, you can see that we have this magma coming up, and along this edge here where this heat's going on is where we're going to start seeing this variation, this metamorphism happening here. So we have the heat there, the pressure of the upper rocks pushing down onto it. We'll see that occurring. We can also have regional metamorphism, and that's where we see two plates coming together, two plates interacting along a fault system. And that's where we're going to have a lot more pressure, and that pressure is going to generate some heat. So we might not have this magma intrusion that we see here for contact metamorphism, but we're still going to have this super pressure here, and then we'll have the heat as well from the center of the earth. Okay, so let's talk about what causes metamorphism. If you remember with metamorphism, what we're talking about is starting off with one rock, and it's going to apply heat and pressure, and that's going to form it into a new rock. So it's going to change, and there's chemical reactions that are going to occur so that this original type A rock here is going to go through these reactions and form this new rock, this new metamorphic rock here. So these are metamorphic rocks. So what causes these things? Well, the first one's going to be heat. Heat is most important. It's going to drive the chemical reactions. As we heat this rock up, the particles are going to move faster, and that's going to allow them to interact and cause these chemical reactions to form this new metamorphic rock. So heat's going to cause the reactions. We can also apply pressure or stress, and what that's going to do is here we have these space in between these different minerals. When we apply this pressure to it, what it causes is all these particles are going to get closer together. And as they get closer together, sometimes they'll start to react that way, and that's how we can form a new metamorphic rock. And then finally we have these hydrothermal solutions. And the hydrothermal solutions are going to be really hot. That's where they'll get a little bit of heat. And they're going to be under pressure, and they'll cause that as well. But this will cause it kind of to cook or to boil or something of that nature, and that's how we get these other metamorphic rocks forming that way. So our agents of metamorphism are going to be heat, pressure, and these hydrothermal solutions. Now, one of the terms that you're going to hear an awful lot of when we talk about metamorphic rocks is whether or not it's foliated. And foliated, as we can see over here, is just where you're going to see these different banding of the minerals here. Okay, so as we apply heat and pressure, if it forms some bands, then we call it foliated. So if you look at a metamorphic rock that doesn't have it, those are going to be non-foliated metamorphic rocks. So quite simply, we break them into two classes, whether or not they have this banding. And if they're banded, they're foliated. If they're not banded, then they're going to be non-foliated. So let's take a look at our foliated metamorphic rocks. So we can see that we have increasing metamorphism, bigger and bigger changes as we go down. So if we start off with some shale or some mudstone or some siltstone and apply this heat and pressure, we get a very fine grain, because remember, the shale, the mudstone, and siltstone are very fine grain sized, and we can make slate. Okay? As we take this slate, we can then put it back in over here as a parent rock, apply more heat and pressure. It's going to break along these wavy surfaces. It's going to have a glossy sheen. Notice now the sizes are getting a little bit bigger because we've squished them together. They're starting to react, and we end up with phyllite here. This phyllite, if you notice, will come down over to here. We apply more metamorphism, more heat and pressure, and we can form schist. And then our schist shows up here with other granite and volcanic rocks. And if we add a lot of heat and pressure, we can end up with this gneiss over here. And that's where we're going to see this medium to coarse grain sizes inside. And notice these are foliated, so we're going to look for banding, especially in these guys, because they all have these little stripes and bands inside of them, which shows us they're foliated. Okay, so now let's take a look at non-foliated metamorphic rocks. Non-foliated metamorphic rocks are basically going to get named from what they're coming from. So if we take limestone and we apply heat and pressure, we're going to end up making marble. If you take quartz and some sandstones, notice we're going to expect a little bit larger grains, and what we're going to end up with is quartzite here. And then finally, if we take this bituminous coal, we're going to apply the pressure. We're still going to end up with a fine grain. And remember, this one is plant-based. That's how we get our anthracite coal that way. So when it's non-foliated, its parent rock is going to play an important part in determining what it is. Okay, so that does it for this video. As always, good luck in your lessons, and we'll see you in the next video.